Gels. Gels are the special type of colloids in which liquid dispersed in solid. So this is a liquid in solid colloid. We can also say this is the partially coagulated, it is a partially coagulated substance, partially coagulated colloid. To make it clear, consider this A is a colloidal system. So what happens when coagulation occurs? These particles, these colloidal particles aggregate to form aggregate. In coagulation, these particles aggregate, and this is called coagulation. Coagulated substance. So we can name it as C. So actually, gels are partially coagulated substance. That means what happens is these colloidal particles get closer and form thin and form thread-like structures. The interconnected thread-like structures, these interconnected thread-like structures are actually called as gel. So this is this form B. Form B is the gel. So gels are the partially coagulated substance. This exists in between the colloidal and coagulated state. So these are the partially coagulated substance. So actually the process of the gel formation is known as gelation. Gelation. What happens in gelation means the colloidal particles get closer and form a thread-like structure, and the thread-like structures interconnected to form gel, and the phenomena is known as gelation. And the gel formed here have a jelly character. Based on the reversible and irreversible nature of these gels, these are classified into two. The first one is elastic gel and the next one is non-elastic gels. Elastic gels are reversible gel, while non-elastic gels are irreversible gel. Elastic in the sense, consider gel. When water is removed from this, that is when dehydration occurs, removal of water occurs, it converts into a solid form. That is, gel solidify when dehydration occurs. And we can easily convert it back the solid substance into gel by adding suitable amount of water. That is, when gel is undergo dehydration, it converts to solid form, and by the addition of water, we can convert back the solidified form into gel. That is why it is called reversible, and these reversible gels are known as elastic gels. Examples are gelatin and starch salt, some common examples that are familiar to us. Then coming to non-elastic gels, these are irreversible. That means when gel undergo dehydration, when water is removed from gels, it same as here, it converts to a solid form, that is a solidify, but we cannot convert back this solid into gel by adding water. We cannot convert back solid into gel. That is why it is irreversible, and these are non-elastic gels. Examples are ferric hydroxide gel, then silica, alumina, are some examples of non-elastic gels. If we add more point to this, we can say elastic gels are non-rigid. That is why the back conversion is possible. But in the case of non-elastic gels, these are rigid substances. So that is why when gel solidifies, it converts into glassy crystals. When silica or alumina dehydrated, this converts into glassy crystals, and the back conversion is not possible. Then, why these are non-rigid and the non-elastics are rigid? Because the attractive force between the elastic gels are electrostatic. While in non-elastic gels, the attractive force between these particles are covalent. So, let's look at the preparation of some elastic and non-elastic gels. For example, if we have to prepare elastic gel, we have to just cool the lyophilic colloid. So, we can prepare elastic gel by simply cooling the lyophilic colloid. So, elastic gel will be formed here. But in the case of non-elastic, the process is a little bit specific. So, we can say if we want to prepare silica gel, what we have to do is we have to add concentrated hydrochloric acid into sodium silicate. So, if we have to prepare silica gel, what we have to do is we have to add concentrated HCl into sodium silicate. Specified amount of concentrated hydrochloric acid into sodium silicate. So, these are all about elastic and non-elastic. These are all about the comparison of elastic and non-elastic gels.